Okay, now that we spent some class time practicing scientific notation, we can use those features to quickly multiply and divide large or small numbers using exponent laws as well. So let's go through and let's review a bit. How do I get something in scientific notation to standard form? Okay, remember what we want to think about. Think of your number line, okay? Think of 0. The right side are all your positive numbers. The left side is all your negative numbers. So since I have a positive exponent, I'm going to take my decimal point and go towards the right. So I just went 4. I've got to put my zeros so that my number is 29,500. Let's try that again. Here's a 7. So if I write 5.8, I'm going to move it 7 times. There's 1, 2, 3, 4, 5, 6, 7. My decimal's here, meaning since there's 6 swoops, okay, I need to place 6 zeros. 2, 3, 4, 5, 6. Now, sometimes people don't know where the comma goes, so I kind of start over here at my decimal and count 3 and then 3. Now let's go look here, and I'm going to shift color so that you understand I have a negative. Since my exponent's negative, I'm going to go to the left, the direction of my negative side of my number line. So I take 3.4 and I move it 1, 2. So my answer, I fill in a 0, is 0.034. Now really there should be the 0 here as a placeholder for the ones place. So here's a -5. So I'm going to take my number and I'm going to go 1, 2, 3, 4, 5. I've got to put in my placeholders of zeros. And I put 4 of them in. So here's how I do this. 1, 2, 3, 4, and then my number. Okay? But remember, when we write something that's in standard form to scientific notation, okay, I'm going to look where my decimal is. I'm going to go 1, 2, 3, 4, 5. 9.74 times 10 to the 5th. Remember, if my number starts out as a whole number, I make a positive exponent. If it starts out as a decimal, it's a negative exponent. When the decimal is out of sight, place it on the right. And I'm going to go 1, 2, 3. So my answer is 7.2. And there are 3 little swoops, so the 3 is my exponent. If I come down here, there's lots of zeros. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to stop there because I only want one number here in front of my decimal point. Times 10. Now let's go back and see how many times I did this. There's 1, 2, 3. You see what I'm talking about? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it started as a decimal, so it's a negative. I'm going to go 1, 2, 3 to get 2.59 times 10 to the -3rd power. Now, there's going to be a trick that will help you do this, but let's see if you can see the pattern. Okay, this is not in scientific notation yet, so I need to get it there. Okay, so let's take a look. My decimal at this point is right here. If I moved it 2, okay, I'm moving it 2 times to the left. So if I'm moving it to the left to get it to scientific notation, I'm going to add. Remember, it was a positive. So when I'm here, I'm going to add 2 to give me a 5. Okay, here's my decimal. I'm going to go 1, 2, 3. So technically, ladies and gentlemen, my number was a whole number. So I moved to the left. So left add, but I need to add 3 here, which is going to leave me with a negative. Here this time I need to move back 1 because my number is a decimal. So this becomes 6.7, but since I moved my point to the right, remember this went right. I'm going to subtract 1 to get times 10 to the 3rd. I'm subtracting from what's already there. And what I'm subtracting is how many spaces I moved. So let's look here. 1, 2, 3, 4. 2.3. I moved it 4 times, but I'm subtracting from this. So negative 1 minus 4, that's how I got my negative 5. So how do I remember this? How can I figure this out? Well, it's simple. Lars. Okay, and I'm going to kind of color code this. Left, if you move something left, you add to your exponent. Okay, if we move something right, I subtract. This is only when you're given something and it's not in scientific notation yet, but it's also not in standard, okay? If it's just a number, that's standard form, we do our normal stuff, okay? So here's what we're doing. We are, if you move the decimal left, add the number of spaces. If you move the decimal right, subtract the number of spaces. Lars, left add, right subtract. Okay, why is this important? Well, it's really going to come in when we multiply and divide numbers. Here's what we're going to do. We multiply or divide just the number part. Okay, that's the first step. So let's shift here for a minute. Then, using the product rules of exponents, that's how we combine our exponents. If I'm dividing, I use my quotient rule. So let's remember here something for a second. My product rule says I add exponents. My quotient rule says I subtract. And then we might have to do Lars in order to adjust and get it to scientific notation. Don't freak out. Let's go see this in action. Okay, here's what I mean. Look at your steps. They're right above. Step 1 was simply to multiply your numbers. So we're going to multiply 4 times 6. Okay? And what that gives us is 24. But then I need to do my product rule. Okay? So here I have 10 cubed times 10 to the 4th. Well, think about this. This is what we did all last week. 10 cubed times 10 to the 4th. Well, bases are the same. So I write my base, add my exponent. So that I get times 10 to the 7th. Now, is this in scientific notation? No, it's not. Because right now my decimal's here. So I need to move it 1. I move to the left, so I add. So my final answer is 2.4 times 10 to the 8th. Yes, did I go through that quickly? But that's the positive of a pause button and a rewind button. So let's look at this one. Now, I have 9.8. Everyone see this? And I have 7.5. While you could take out a calculator, you can also go to the side and multiply. Because this could be on a non-calculator day. So 8 times 5 is 40, carry the 4. 9 times 5 is 45, plus 4 is 49. I need to skip a spot because I'm moving over a place value. Okay, 7 times 8 is 56, so I write a 6, cross this out, and I put a 5. 7 times 9 is 63, plus 5 is 68. When I do the math, 0, 9 plus 6 is 15, carry the 1, 8 plus 4 is 12, plus 1 is 13, carry the 1, 7. So I have 2. There's one number after the decimal, and here's another, meaning I move it 2 times. So I got 73.5. But I also need to do 10 to the 4th times 10 to the negative 3rd. This is our exponent laws, ladies and gentlemen, meaning bases are the same, write the base, add the exponent. So when I look at this, it looks like it's in scientific notation. However, this decimal here needs to be over 1. The only thing that allows you to move it left is if I add here. So I get 7.35 times 10 to the 2nd. Ladies and gentlemen, you cannot just add or move things because it makes it easier for you. There are rules to keep things balanced. So I think most of you do better when you see something written in this form. This is what it means, okay? It's always going to be your number on top is what comes first, okay? And then we have your number on the bottom comes second. So here's what I advise you. Separate this, ladies and gentlemen. 3 divided by 4 times 10 to the 7th divided by 10 to the 5th. At this point, you should know 3/4, 3/4. Think of money. What is 3/4? 3/4 is worth 75 cents. Well, here I've got the bases are the same. So I write the base and I subtract these exponents. So take a look here. This 7 minus 5. Okay, so I'm going to subtract and get a square. But is it technically scientific notation? No, it's not. So I need to move this to the right once. So I moved right, meaning I subtract. And I only moved once. So my final answer is 7.5 times 10 to the 1st power. Okay. Take a look here. Separate these out. Numbers with numbers. So 9 divided by 1.2 times 10 to the negative 6 over 10 squared. So let's go do some math. The number on top goes inside. The number on the bottom goes outside. I have to move this over so that it's 12 here. And if I move it over on the outside, I have to move it over on the inside. Ladies and gentlemen, that is dividing decimals, and we went over that at the start of the year. So now you ask, how many times can 12 go into 90? Okay, it's going to be less than 10. So test it. Try 7 if you don't know your 12 times tables. 4, carry the 1, 84. Minus 84 gives me 6. So that went in 7 times. I add a 0, bring it down. This is going to go in 5 times. So I end up getting 7.5 times 10 to the, well, I'm doing subtraction here. Negative 6 minus 2. Ladies and gentlemen, your integer rules will kill you. Negative 6 minus 2 is a negative 8. It's always the number on top minus the number on the bottom. So here's what I want you to do. Take a look at this word problem, okay? What we're going to go through is highlight key features. The mass on Earth is given by this number, 5.79 times 10 to the 24th power in kilograms. The mass on Jupiter is 1.9 times 10 to the 27th in kilograms. So right now, let's take a look. They're in the same measurement, so that's good. We need them to be the same, okay? They want to know how many times greater. Ladies and gentlemen, this does not mean to multiply. This means to divide. You need to know that, okay? I want you to attempt this one and your answers in scientific notation. I also want you to go back and try the next two in each of the multiplying and the dividing sections. I'm going to be looking that you have 2 besides what I solved. This is a lot that was thrown at you, but we need to understand this. If you have questions, ask.